All right. Hello, everyone. I'm Jinhua Zhao, Professor of City and Transportation Planning at MIT. Welcome to the MIT Mobility Forum. This is organized by the MIT Mobility Initiative to showcase the state-of-art transportation research across the institute and beyond. Today, it's really my pleasure to have Professor Hamsa Balakrishnan to join us and share with us her research on traffic management challenge in the advanced urban mobility. The advanced urban mobility operation are capturing people's imagination these days. They're most likely to be electric, highly automated, or even autonomous, right? And they promise to transform the way in which we transport both people and goods. How to deploy this new technology, what are the business models, under what policy framework, there are still very much open questions. Will they add competition to the already very constrained urban space resources, right? How do you manage the traffic, right? So here, particularly, if you think about the road transport versus air transport, they somehow follow a very different norms of operation, of business model, of safety standard, of a policy regulation, right? So today, I'm really glad that Hamsa will join us and share with us her thought on this. Before I formally introduce Hamsa, I want to re-emphasize the norm of this forum, which is everybody contribute one idea, right? I encourage everyone to type either a question or a comment in the chat so that we can engage everyone in this process. So just to warm the audience up a little bit, I will invite everyone to type in the chat your organization, your city, and your local time. Right. So I would say MIT, Cambridge, and Massachusetts, 12, no. Right. So that somehow get a sense of who the audience is. Great, thank you. Please keep typing this so we'll get a sense of the audience. Hamsa is a William Leonhard Professor of Aeroastro at MIT. He leads the Dynamic Infrastructure Network and Mobility Research Group. Prior to joining MIT, he was worked at NASA's Ames Research Center. Her research lies in the design, analysis, and implementation of control and optimization algorithm for large-scale physical infrastructure, with a particular emphasis on air transportation system. These include airport congestion control algorithms, air traffic routing and airspace resource allocation method, machine learning for weather forecasts and flight delay predictions, and a method to mitigate environmental impact. Her research spans theory and practice, including both algorithm development and real-world field test. He was recipient of American Automatic Control Council's Donna Ekman Award, the AIAA Lawrence Sperry Award, and the inaugural CNN Award for Operational Analysis. So without further ado, let me pass the forum to Professor Hamsa Balakrishnan. Hamsa, please.
Thank you. And you can all hopefully see my screen.
Yes.
So thank you again, Jinhua, and thank you all for joining us today. I'm really excited to talk about some particular challenges that I see in advanced air mobility. And I'm going to try to keep it down to 20 minutes. I would really like us to have a discussion because I think this is a topic that, as Jinhua said, captivates a lot of our imagination. I'm going to talk a little bit on the system side of what I think the role of the open questions are, in particular, where we need really more R&D research to go into make these things a reality. So to start off with, when we say advanced air mobility and we talk about this vision that captures us all, these are artist renditions, right? So this is the one from NASA. You'll see a couple of these. These look like things that captivated my imagination growing up, where we thought we were going to have personal air transport and personal air taxis, and our commutes, from the suburbs to the Bossard to Cambridge were all going to be in the air, so we wouldn't be sitting in traffic. So this is a nice vision. I think a lot of what I'm going to talk about today is why we're not there yet, and what we really need to do to what remains to be done, what remains to be answered in order to make this vision a reality. And since I've spent much of my career so far working on aviation and commercial air transportation, I'm also going to try to focus on some of the differences, why the challenges of how we do traffic management here are going to be different from the way we've done air traffic management traditionally for conventional, commercial aviation. So with this vision, I want to really say that this is not something that's new. And this idea that we're going to have autonomy is something, or things are going to fly on their own, is almost 100 years old. The image on the left is a picture from 1903. It's the Wright brothers' first flight. The image on the right is from an air show in Paris in 1914. And Lawrence Perry is the pilot, and he was the inventor of the first autopilot. And this was a demonstration that the aircraft could actually fly, short distances, straight and level on its own. And the way he demonstrated it was to have his mechanic actually step out. So the person who's standing on the wing is standing there so that the people down below can see that he's not touching the controls of the aircraft. And Sperry himself has, look ma, no hands. The idea being the aircraft is flying itself. So although, so much of what we see now with self-drive and self-flying seems like a modern invention, it's more than 100 years old. If we take this, okay, these are short distances, aircraft doing something very simple. If we think about more complex flying, this is a real New York Times headline from 1947, right? Robot piloted plane makes a safe crossing of the Atlantic. So this is what we would call, unmanned, unpiloted aircraft. It says no hands-on controls from Newfoundland to Oxfordshire, takeoff, flight, landing, all fully automatic. If we think about it, 1947, this is a mechanical computer, right? It's a mechanical brain. There are several things that are pretty remarkable about, that I found remarkable about this article. There were civilians on board, there were journalists on board as observers on this aircraft, which was a large DC Skymaster, which was retrofitted, which was fitted with a mechanical brain. And then when people talked about, well, what would you possibly use this sort of self-flying aircraft for? They certainly saw military wartime applications, but they said, well, during peace, you're going to use it as a cargo carrier, right? Like package delivery. So if you think about this is 75 years ago that, this flight happened. So then I think the question is, what are we doing now? Why is it that we don't see that vision that we saw earlier of this sort of, autonomous aircraft flying on its own? And we've not been able to, this was a demo, right? You shut down the airspace, you had one aircraft that was flying across, you had rudimentary navigation aids set up on the ocean in between that it could follow. We've not been able to do this at any type of scale, right? And we haven't been able to do this in a way that's safe and repeatable, that we can actually commercialize and do that. And that's really, the challenge. And the thing that I'm going to talk about today are those system level things. What does it take to integrate this into the rest of the airspace that we have? What does it take to have more than one of these aircraft? Understanding, of course, that the aircraft don't look like this DC Skymaster anymore. In some ways, they're a lot more intelligent in the sense that at least just in terms of the sheer computing power on board any aircraft right now, it's a lot more than what was on board this aircraft that flew across. So these changing skies, as I said, there are many, many artist renditions, all of which look alike, look quite similar. This is from Airbus, and this is from a few years ago, where the idea was this is the future of urban mobility, was going to be these personal air taxis. One of the things that gets used, in this is urban air mobility. The idea being that it's going to be air taxis in urban environments. Another for smaller drones is unmanned traffic management or unmanned aircraft systems. I'm going to use advanced air mobility as a sort of catch-all, which doesn't include just urban applications or passenger flights, because it's becoming increasingly clear that a lot of the applications of these sort of aircraft are going to be potentially in rural areas, disaster response type scenarios. Probably, downtown Boston, the urban environments might be the hardest place, most challenging places to actually have deployments of these aircraft. And so I'm going to use advanced air mobility almost as a catch-all to say it's all of these. And the aircraft themselves have changed in what we're talking about. I said certainly they have more computing on board. The other big change is they're much smaller. Some of them, they're doing a variety of things, some of them carrying people, some of them carrying cargo, small packages, large, cargo operations. The way they are powered inherently is electric. So we're looking at electrically powered aircraft, and we're also looking at not the large fixed wing aircraft necessarily that we that a lot of commercial aviation looks at, but instead what are called vertical takeoff and landing aircraft. And the idea is that you don't have the luxury of the real estate to build a large landing strip that you would need in urban areas, or in many areas it's too expensive. So you really want to be doing vertical takeoff and landing on what are called vertiports. And so the aircraft look different, the computing looks different. The problem that we're trying to solve is really something that's more than 100 years old now. So the second thing, and Jinwa asked this before I just started, which is what is the scale that we're thinking of? And apart from the form of the aircraft, the thing that's really going to change is the scale. These are projections. We don't have anywhere near this number of aircraft on in the skies right now. So the projection on the left is from Airbus, and the projections might be 20,000 flights per hour over Paris by 2035. Currently, there's about 100 flights per hour over Paris. So when you think about what is a change in scale, it's it is unprecedented numbers that we're thinking about if these projections pan out. And really, the question is, will they materialize or not? And I think that's still an open question. Nobody knows. But if we can make the system work, I think this is the projection of what demand might look like. It's similar for the not just the number of flights per hour, but the sheer number of objects that you might be thinking of. So the projection on the right from 2020 from the FAA was that we'd have 2 to 3 million of the smaller UASs, the smaller drones, not carrying people, but carrying smaller packages and so on, under 50 pounds. These numbers are more than the number of commercial aircraft we have, right? So again, these are orders of magnitude that we're thinking of. But partly because the demand projections look like this, and people say, well, if we can make the system work and have these these operations become a reality, this is the kind of demand, and you can build business models out of this. There has been an enormous amount of investment that's gone into basically the drone industry in some form, right? Whether it's passengers or not. So this is a chart through 2020, but one of the things we see is these are just global investments in the drone industry. The darkest blue lines here are drone companies. So these are aircraft that make drones for primarily cargo type applications, carry payloads. The slightly lighter blue lines, which are now taking off, are the are increased towards the end, are the urban air mobility with passengers, right? These are passenger drone companies. There's some investment down here on counter drone companies, because you now have security implications of this. And then that almost negligible amount of investment that's happening is on traffic management, right? The UTM stands for Unmanned Aircraft Systems Traffic Management. And so if you think about building the vehicles themselves, you see that pretty consistently, a lot of the investments are going into building these aircraft, designing and building these aircraft, because they are new power systems, they are new airframe designs, they are new ways of autonomy, right? They're more autonomous than they used to be. And so That's really been the focus of all the investment. But there's very little in what happens when you have 5 or 6 different or more than one operator actually flying in an airspace, and there's this kind of demand. You actually need traffic management, and there's very little work that's gone in there. So I'm just going to talk very quickly about some of the challenges in that aspect. The other thing I should point out, since I said I will highlight differences from commercial, conventional aviation and everything else, is this investment, which used to be largely public sector investment, is not at all from the public sector or from large companies that are exclusively like aircraft manufacturer type companies. This is almost entirely venture capital that's gone in here, and and it's gone in here because of those demand projections, right? Like, people think that there's a business model if we can make this a reality. So I think from the traffic management point of view, the reason we need to answer those questions is either this investment actually leads to something or it doesn't. And the difference of whether it happens or not is going to be, can we get the system to operate as a whole? So based on that, I'm going to sort of say that there are 3 system challenges that really end up being important. The first is just the scale, right? Like, to go back to Jinwa's question, what is the scale? Scale is so large that we really need to think about how do we achieve efficiency at these scales, right? Like, there's going to be, if there's enough demand that you're going to have congestion, then you have to think about actually some form of efficient use of resources. So how do we do that? The second thing that's quite a difference from conventional aviation is that this is a different competitive landscape. So we are used to a competitive landscape in aviation where you had airlines, typically at the larger airports. The airlines have similar business models, right? So they can have some differences, but they're, serve its passengers. They kind of want, delays matter. Everybody cares about the same things, and roughly, you have a few of these, and it's a little bit more homogeneous in the nature of the competition. Whereas now you actually have operators who are doing different things potentially. So you could have someone who is flying 50 aircraft or 40 aircraft. You could have someone who's a single aircraft, someone who's carrying, who's delivering, medication that's time sensitive, someone who's delivering a toothbrush, someone who's doing a photography mission that, is not time sensitive, someone who's actually doing a photography mission, but is doing it because it's a disaster, they think it's a fire and they're trying to decide what to do, like a first responder. And so the question becomes, how do you balance these different objectives? So it becomes that much more important to deal with it in the competitive landscape. And the competition also leads, because of that, to 2 concerns. The first is privacy becomes important. So earlier, when you had the FAA managing traffic, to some extent, you could say you have to publish your flight plans, hours in advance. You need to tell people what you're going to fly. The demand, you actually have a good handle about it. Now, I mean, it's not obvious that it makes sense that the operators will share information automatically because the incentives are not clear. And simple example is the US has a drone ID rule which says that every drone has to broadcast its ID at all times. As soon as they announced it, the first thing that happens is there are complaints about privacy violations. So firstly, if you think about the rideshare application, and you're on the ground and you ask competing rideshare companies, Uber and Lyft, and you say, you need to always be telling us where you're expecting demand and where you're going to send your cars to, you can see why they're not going to be happy to share that information, because there's certainly competitive advantage to not sharing that information. And the second part of it is, even if you could convince them to share that information, they may not be able to, because if you say, let us know 3 hours in advance what your demand is going to be, and it's a on-demand application where you don't actually know you got to conduct that flight for the next 15 minutes, they're not going to be able to share it. So that sort of information sharing and privacy becomes important. And the second is actually the notion that I talked about, where in this competitive market, fairness becomes more important. And one of the things that in the US, the FAA and NASA and everybody, the government has said is they actually want to equitably serve airspace users with different priorities. And so the question becomes, how do you do this? And not have a clear first mover advantage. So the example in Australia was as soon as Google moved in and started using Canberra airspace, immediately there's a concern that nobody else can move into that space because they sort of own the airspace, which you want to avoid. So that's really the three challenges that I would like to discuss, and I think there are parallels in other systems as well. I'm going to bring up the sort of elephant in the room on the system management thing, which is even if we identify the things that we need to deal with when we're managing traffic, there is an open question now on who's going to manage the traffic. So conventional aviation, we started with air traffic controller. So this is a real person, Archie League. He's known as the nation's first air traffic controller. The moment you had more than one aircraft landing or taking off at an airport around the same time, you needed someone to make sure that the two weren't running into each other. So this is at St. Louis Lambert in 1925. From there, we've gone to the modern air traffic control towers. But if we think about advanced air mobility and you think about what the government says, they have said in the concept of operations that the FAA will not play an active operational role in managing the aircraft. Namely, if we ask, okay, we know what's going to be difficult about traffic management, but who is going to do the traffic management? Pretty much all around the world, the traditional air navigation service providers, the people who manage this traffic, say, we're not the ones who are going to be dealing with this. So that is a bigger concern if we think about how little thought and how little investment is being paid to the traffic management piece in those, the bar charts that I showed, because, well, you don't even have the conventional way of managing the traffic here. So those are really, the four questions, right? Like there's the efficiency piece, the privacy piece, and the competition and fairness piece in these competitive markets. But then the big question is, even if you sort of come up with ways to do that, this has to be done largely in the private sector. And I think that's going to be the other challenge here. So the three things that very quickly I'll talk about, and we can talk about in more detail here, like I'm going to have one slide on each of these. So the first question we can ask is, if I'm a service provider and I happen to have an airspace, how do I manage traffic here in a way that's efficient and fair? And I'll highlight a couple of things we've done in that. The second question is, the other part of competition will be that if I'm a fleet operator and I have multiple customers, we have to think about how do you manage those in an efficient and fair manner. We've done some work in that. And the biggest question now that we don't actually have somebody like the FAA managing the traffic, we do actually have to think about competition between service providers and how we would incentivize cooperation between them to get efficiency. And I think that is the biggest unsolved, unaddressed problem here. So if we think about the service provider, the numbers are really large, but we can think about ways in which we would solve this. So one way on the left, and we've done some work on this, is just Alex has worked on this as well. This is an optimization problem, right? It's an optimization problem where we want to solve things at really large scale. This is not that different from the air traffic flow management problem that Professor O'Doney first mathematically wrote down, formulated in 1987. The difference is it's much larger, and some of what we can do in terms of sharing information and doing it in a centralized manner has changed, but we can still we have a handle on how we would answer these questions. And then what we've done more recently is actually say, well, if you want this at true scale with really large numbers, you can think about it working like the road does, right? Like have rules of the road and come up with protocol-based methods to do congestion management and look at different fairness metrics and solve these. So we've done work in both of these aspects of if you have a service provider whose job it is to manage traffic, how would you do it in a way that balances efficiency and fairness and do it in a computationally tractable manner? The second piece, I think about it, that we need to think about is from a fleet operator, an aircraft operator, who has multiple customers. So I'm going to use an example to show what the problem here is and one of the solutions we have. So let's suppose that I am a fleet operator who has 5 drones. And these are just almost hobby drones. They have a battery life of about 15 minutes. We need to come back to the base to recharge this. But I also have 5 customers, right? These 5 applications. Since we're based in Cambridge, the things that we care about are traffic and parking. So we want to, in real time, keep monitoring traffic. We want to look at parking spots. To fly these things, you actually need cellular connectivity. So we also want to be mapping cellular connectivity, which is what this task iPerf does. We might want to measure air quality, right, in certain locations over the city, and we might want to do, roof infrastructure inspection. And so these sensing tasks are going to be spread over a city in different locations. And the question becomes, well, how do I actually serve all these customers? And you don't want to, a fair but inefficient way of doing it will be to just give each customer one drone, one vehicle, right? And it's going to be inefficient because the tasks don't all show up at the same time and are not in the same cadence. So maybe the traffic app, we want to be continuously monitoring it, whereas the parking one, we just want to come back every 10 minutes. The roof one just shows up whenever, and you don't want to have the vehicle sitting idle when it could be used for another task. So you really do want, for efficiency from the efficiency point of view, to multiplex, to share here. Whereas you want to do it while also being equitable across applications. So our approach here is to actually come up with an algorithm that trades off short-term fairness for long-term efficiency, to gain long-term both fairness and efficiency. And what we can show is that in these type of applications, you can actually get to close to your optimal throughput while not starving, while not sacrificing certain fairness metrics, like starving certain tasks. So the example here would be, Mobius, which is our solution method here, looking at maximum fairness. There are other fairness metrics we can use. Compared to the maximum throughput, gets almost the same throughput. You serve almost the same number of tasks, the rate of tasks. But then, if you just did pure optimization without considering fairness, what you would do is this air quality sensing task, because it's a little bit out there, you wouldn't send anybody there, right? You'll keep doing just the cellular throughput task because it's easier to just keep hitting all of those points cyclically. And the worst one in terms of efficiency is going to be the one where you just dedicate drones, because if you have an application that joins late, that vehicle is just sitting idle when it could be doing something else. And so but this idea that we need to navigate efficiency and fairness when you have competition is something that shows up here as well. And then quickly, the third piece, and as I said, the sort of completely open piece, because it's unprecedented, is how do we actually incentivize cooperation among service providers? And we need to incentivize cooperation. And then we've done some work here that I'll talk a little bit about. The bottom line is, if everybody has their own region, let's say, and does not cooperate, it's going to be very inefficient because, much like our communication system, we actually want aircraft to go from one region to the other. So you can imagine that if there's a service provider who manages traffic in one region and someone else who manages traffic in another region, and they don't cooperate, they're going to do very inefficient things to traffic that's going to other regions. And so we really need to incentivize cooperation here. As I said, this is sort of a really open area. So we start with, what do the concept of operations say, right, that the FAA and NASA have put out in terms of service providers. And we focus primarily on service providers who compete. So service providers who are providing traffic management services. Now, there could be a service provider who's providing weather information, right? And they're not competing. So if I have a service provider who's doing traffic management and one who's doing weather, it's complementary services. They're going to they're incentivized to cooperate. Whereas what happens if they're both doing the same thing is sort of the interesting question for us, and also bigger challenge, because you actually have a competitive environment there because they're private as well. So again, looking at what the concept of operations say, they say things like they're going to be a federated set of possibly private actors, right? And in fact, right now, it seems like they're going to be largely private. because everybody who's developing anything is actually a private entity at this point in terms of traffic management. The second thing that they say is that we're not going to give the Boston area to one service provider and give New York City to another service provider. So we do know that there's going to be multiple service providers who can provide traffic management services to the same geographical area. And then we know also that the same entities can play multiple roles, namely aircraft operators and service providers can be the same. If we think now about what we know from the internet and communication systems, all of these are going to be very, very murky. The third one in particular, if you think about who's building traffic management services right now, it's the people who are building the aircraft, because you can't fly the aircraft without having some traffic management service. This is the equivalent of a net neutrality question, right? So if I'm both the content provider and the communication network, I'm going to throttle my competitors' packets, right? My competitors' aircraft are going to get delayed. So in a competitive environment, there's these things we believe are going to lead to weird behavior. The last two I grayed out because the last one is just what happens tactically. If an aircraft sees another, they deconflict, that's going to happen on board. And then the strategic, the strategic demand capacity balancing is what I talked about sort of in the first part. So I think those we have a handle on, but the three parts that are completely open questions are out here. So the last thing that I want to say with some very recent work that we'll have in the ATM seminar this year is that first piece. What happens if you have federated, possibly private service providers? What we have done, and you can have this airspace where you can have one service provider who has a monopoly. You can have two service providers, three service providers. If I'm an aircraft operator who's also a service provider, I have to think about which one I contract with, right? So there's going to be those kind of questions. And what we've looked at here, because it's going to be in the private sector, is really coming up with a profit sharing mechanism that we can show will incentivize cooperation between these. And by cooperation, we mean collaborative congestion management. So with that, I would say that the open challenges, and really this is as much a call to action to people, and I would love to hear how this gets dealt with in other transportation systems, where you have private infrastructure providers or private traffic management, is how we deal with any of these issues, right? Like how do you get efficiency in these competitive environments? In particular, how do multiple entities manage operations, manage traffic in the same region? How do you mitigate, what in these competitive environments that's likely to happen, namely net neutrality type effects? And then more broadly, when do market mechanisms work? Or is this one of those things where we should be thinking about, public policy, namely you need regulatory action, otherwise you would not solve this. And it seems like certainly the net neutrality question, we have seen that, regulation might be the only way to go because the incentives are not aligned. And so those are sort of the open questions that I think, I'd love to hear thoughts about. So sort of to wrap up, this is coming to soon, whether we like it or not. I mean, as I said, this was a year ago. Walmart started operations in 6 states. They want to expand. The interesting thing is they also realized that in order to actually offset the cost of delivery, they're going to have to look at other things that the drones are doing. So the multiplexing thing is becoming clear that business models have to consider that. As I said, a lot of the applications that seem important, this is important in, is going to be in things like disaster response, where you don't actually have ground infrastructure, it's been damaged, and you want to evacuate people quickly. And then, this is about a month ago when Zipline is also started delivery, right? And so right now, you don't have two of these companies operating in the same region, but that's bound to happen if those demand projections materialize. So I'm going to stop here. This is basically where, if you think about those three challenges and what was said in terms of the goals of the AAM system by the FAA and NASA, question is, how do we get there? So I'm going to stop here, and I would love to hear thoughts and discuss any of these things.
Great, thank you so much, Hamsa. So here I will invite Professor Tom McNanty and Professor Alex Jacolet also join the spotlight. So Hamsa, I will start with some questions from my side, and then we'll invite both to join as well. So I think it may be useful to contrast between the road traffic system versus the air traffic system, right? If you think about the road traffic system is entirely localized, distributed. People negotiate at agent to agent level, right? We have some standard rules, but there's no central control. That probably due to the fact that just the sheer scale, you cannot do that, right? But in the airline industry, it's the opposite, right? It's very much controlled, very centralized system. But when the AAM, as we mentioned, the object, the sheer number of objects will increase by, let's say, 2 or 3 order magnitude, I would think we're just in between. See, in Paris today, you have 100 flights. Let's get to 20,000, that's 200-fold, right? But it's still much smaller than the number of cars on the street, which I talk about the millions level, right? So in between, these two totally contrasting control philosophy here, right? What do you envision this field will go into, right? Any third option that can take advantage of both sides, and which part should be the more of a control function, which part should be a localized negotiation?
Yeah, and I think that's sort of something that we've been grappling with, right? Like, and so one of the reasons we go to looking at protocols and sort of rules of the road-based approaches is to say, well, in the extreme case, that works on the road. I think the reality here is that the costs are much higher, that if you actually have the kind of inefficiencies that you have in a congested city, it's probably not going to be something that will be a viable business model, right? So you can't possibly have the kind of delays that like you see on the ground in the air. I think there is the right way to maybe think about it, and the way we've been thinking about it a little bit is you do care about efficiency, you may not have the control. So the protocols will kick in when you're trying to go from one service provider to another service provider. But if I'm a service provider who is managing traffic in my region, I think I do want to be efficient in some way, right? Because the cost of managing that traffic has there is a real cost with making sure that being responsible for the traffic, which is not there in the current on the road right now, because every individual driver is their own person. And in the extreme case, it might be that, right? And so what we do is try to see if the protocols get us to some measure of what might be optimal, at least in a super myopic way. But I also think that if you actually have someone else in charge of responsibility, which is the direction that they're going in, then there's going to be, I want to do it with, you're going to compete on that. If I have 2 service providers, I'm going to be a service provider who's going to say, use my airspace because you will get a more efficient route. So I think, so the right answer might be somewhere in between. And I think, the shift, as you said, is it's super decentralized right now. But if you think about who's doing the metering onto a freeway, or who's doing the traffic management of that sort, that is still to some extent public policy, right? There's one person who's doing that sort of congestion management decision, even in the road system. And we're now talking about maybe that's not the case either. And I don't know how that works.
Right. Thanks, Sam. So another question is on the safety side, the two systems also contrast very much, right? On the road side, 42,000 people died on the road in the United States, 2021. We somehow the society accepted that, right? We talk about the same, but then on the air side, the effective is 0, right? They're both safety issues, both in the transportation, but we somehow end up with totally different norms, right? So when the AAM comes in, do you think we'll follow a much more stricter airline industry convention that tolerance is 0, or will end up some reasonable amount of accident, deaths, etc. This.
So I think that is a really important question. I think the community is a little bit divided on that, right? When it comes to things like vehicle certification and the ability to tactically see and avoid, I think a lot of that is trying to get the kind of safety levels we've been used to on the conventional side, conventional aviation side. I have not. So as I said, that was probably the most important question that I said we're not going to be dealing with. Namely, we're going to say that if a traffic management service provider says that the number of aircraft in this region is going to be, N, that N is taking into account what they think is going to be what they can manage in a safe manner. The concept of operations actually say that aircraft will tactically avoid each other, right? Like they will sense the other aircraft, and the aircraft operator is going to be responsible for that. I don't think we actually have a full understanding of how that's going to work at scale when it's not the same operator. So right now, anyone who flies a swarm or a fleet of drones does make sure that they don't run into each other.
Right. Thanks.
But that's not a competitive environment, right?
Right. Yeah. So the third question, last from me, and then pass to Alex and Tom on this is, the air traffic, of course, open the third dimension. It gives opportunity, but in the end of the day, I have to interact with the ground, right? To touch down at some point, right? Even with the vertical takeoff and the landing, you still have to take a lot of space on this, right? If you talk about the urban air mobility application at scale, how many such vertical port can we, practically build in the city for it to be meaningful at scale, right? So that's another question I also want to pose. But maybe I have Alex and Tom give the comments, and then you can pick up whichever question to ask.
I think Alex has done some really important and fascinating work in answering the vertiport selection and problems. So I was going to say that I think that is an important open question, but we do have people, even at MIT, working on this because absolutely, you need to know where we're going to put them. Yeah.
Right. Thanks. Yeah, Alex, please.
Yeah, thanks, Hamsa. Well, thanks. Also, a shout out to Spencer, who's currently writing a thesis on corridor operations management in this system. So more work to come, but very nice presentation, Hamsa. So first of all, I learned a lot about the technology and like the latest concepts of operations from FAA and NASA. So very good learning experience for me. And then I really like how you bring like all of the system view together, right? Because we have to think of this at a high level and not just at a vehicle technology level, not just an operations research technology level, but like really at the system level. So that's great. We'll have to, it's quite daunting actually how much we're going to have to reinvent everything that we know about ATC and ATM. And so I think that your presentation was really helpful in terms of providing guidance there. I have two questions that I noted down here. The first one is, can you talk a little bit about weather? Because there are conflicting reports here out there and initial concepts of operations again. It's one of the emerging trends seems to be that these vehicles will be very hard to operate under IMC, going back to the safety question that you just answered. But then rain is not rare in cities. And then if we start like looking at the impacts in terms of public acceptability and reliability of the system, that sounds to be like one of the significant risk of these emerging systems. So can you talk a little bit about that?
Oh, thanks.
Yeah, absolutely.
May I invite Tom to add his remark as well, so we can respond collectively? And I want to make sure we have some time. Well.
Oh, okay. Well, I'll finish and add my second question. Then my second question is about if you can. There were a lot of questions in the chat about unintended consequences of the systems as well. Again, in terms of public acceptance and noise impact in particular. So if you can talk a little bit about that as well, and then I will stay quiet and let Tom provide his remarks.
Thanks, Alex. Tom?
So Hamza, a very nice talk. I love the history part in particular. So I live, for those that aren't in Boston, I live in Hopkinton, about 35 miles from MIT. And I take the Mass Pike every day, and it's completely congested, completely congested. It's hard to imagine that there's going to be enough of these air flights to get people from Hopkinton to Boston every day. And as Xinhua said, you have to have takeoff and landing, so you got to have spots to land and all these type of things. So I don't think it's going to take over all the highways and this kind of thing. So Hamsa, I just wonder if you can say a little bit about where things are going to happen first. And you mentioned a little bit about rural neighborhoods. We're clearly going to see lots of drones, but I'm not sure we're going to see lots of things from my house to MIT. And I'd like to have a personal one of these things, by the way, so that I could do that. But that leads to all kinds of equity.
Me too, Tom.
That's right. So back to you.
Okay, thank you. So maybe I will start with Tom's first, because and then it'll lead into Alex's question. So I think one of the things that are particularly challenging now is for this not to be a very wealthy person's alternative, right? And so the real question, I think, that is open to every one of these demand projections is, what is the price point at which we can achieve this for it to be something that will actually have a consequential impact on ground traffic? And I think some of the projections that we see on how much we can get it down to are probably optimistic, right? And they're optimistic in strange ways. So if we think about rideshare companies in much of the world actually heavily subsidized rides to get people into that. And then it had to get much more expensive. And I think at some point that might have to happen here. But I think also the public acceptance piece comes in there as well, where are you know, at what point am I going to be comfortable putting my kid in there to fly, right? Like, I don't know. And I think that varies a lot by person, but there need to be enough people doing that to actually get some of the carpool traffic out, if you think about it. So I think all of these are really super connected with this. You know, Alex said the question about noise and unintended consequences and everything else ties a little bit into that public acceptance and where it's likely to happen. I think the first places will likely be the rural areas, because necessity ends up being higher there, where there isn't an alternative, and just sheer consequences of you know, a package delivery drone, you know, actually having a failure and not making it to vertiport, you know, in an emergency, is likely, you know, in terms of human lives, is likely to be less consequential in a rural area, which is not over a city, than it is in an urban area. So I think for those reasons, it is very likely that you know, this is going to happen. It's also going to be the reason the disaster response kind of things happen is there isn't an alternative. When there is an alternative that we accept, you know, I've come to accept that my 8-mile commute is going to take me an hour. And I think you know, that changing over time and overruling any concerns people might have over safety, I think the jury is entirely out. We don't know. The
way,
question on
my commute takes at least an hour as well. So
there you go. That says something about congestion, right? Like well, the effect of congestion and how nonlinear it ends up being. I'm willing to bet we spend most of the hour in the exact same stretch now. The issue of weather is, I think, on the package delivery drones, Alex is absolutely right, because it's not just rain, right? Wind. The smaller drones are extremely susceptible to wind gusts. If we think about you know, urban canyons, and Vassar Street is a wind tunnel for all practical purposes, right? So these drones, especially the less expensive ones, are going to be more susceptible to wind gusts. And so I think we need a better handle on weather. And I think there is a lot of incentive again. There is a good business model for companies to build weather products for these aircraft. And I know that folks at Lincoln Lab, for example, do a lot of work on the research side, but then there's also the commercialization where you can put it into the rest of the system, right? Because the less expensive the cost of the drone, the more susceptible it's likely to be to some of these things, especially the smaller drones.
Great, thanks, Hamsa. I will give it to Buam for the question or answer from audience. Yeah, please.
Yeah. Thank you, Jinwa. Hamsa, thank you for that presentation. We've had like over 200 active participants in a very, very active chat. So you mentioned the 3 challenges of efficiency, privacy, and competition and fairness. The points you mentioned about initial application in rural areas sort of makes sense and addresses some of the questions on privacy and safety, drones falling from the air, things like that in lesser dense areas. So one question there were a lot of questions on airspace, so I'll try and club them into one. The questions were on the utilization, and segmentation of airspace, and that the concept of having airspace corridors seems to be the predominant direction so far. But this is not the most efficient one. It increases travel time. You could have congestion on these said routes. So is this being done solely for the purpose of separating responsibilities from FAA and the current NAS controls? And what are your thoughts on the efficiency versus just opening up the airspace and not having these corridors?
So I think corridors are one way in which you get that responsibility straightened, right? So I absolutely would agree that the idea that anybody can manage traffic in any region and they have to coordinate is just too complex. We don't know how that works. So the right thing to do is to separate at the expense. There's going to be trade-offs with efficiency no matter what we do. So we need to find a way in which we can design corridors or any other way of partitioning the airspace where we don't sacrifice too much efficiency, but we get some levels of, we know how to handle traffic here. I think that sort of will still raise the question of who's going to manage the traffic in the corridor. So that addresses how the service provider will manage traffic on the corridor. It doesn't answer the question of how are we going to decide which service provider is going to manage traffic in that corridor. And it is not clear that if you have large enough regions, are we going to say that in order to fly a corridor, I need to have the same service provider managing traffic all along that corridor? Because you can imagine that some corridors are going to have much higher demand than others. And so now if you have a competitive environment, it's going to become who gets to manage traffic there. So absolutely, I think that sort of partitioning is going to be the only way forward, but it still raises many of the same questions.
Yeah. A totally utopian, thought. If we have, certain selected service providers in, certain cells, can there be like a mid-air handoff of the package? And, so we have only that a certain provider operating in that area. I mean, it sounds very,
I think that is in the work that we did, that I referred to in our recent work, that is what we assume. We assume that there is going to be a handoff, and we say that to get efficiency there, you need to actually share profit, right? Because otherwise, what is in it for me to take, if I'm not going to get any of the revenue that the other service provider who's handing off to me is getting from their ultimate customer, why am I going to route that traffic in a nice way? So
the other question is about the actually airports and so how will the urban air traffic affect the future of existing airports, and also in the rural areas? The utilization of tier 2 and tier 3 airports in the US has gone down. So will some of these become obsolete? Can we repurpose these land to have more, I don't know, for EV tolls, landing and takeoff, and also for like more logistics, just sorting? So that was one of the questions.
Absolutely. I think people are thinking about, not all of them are EV tolls. There's a lot of short takeoff landing, and there's a lot of airport infrastructure that exists that's not used. It's not in the urban areas, but it's in the rural areas. And I think there is a question. And I think there's potential to revitalize economies in places by bringing this mode of transport. right? Which might be the ultimate way in which the market moves.
I have to ask this question, on the net energy and climate impacts on the large scale use of this technology. So has there been research done on, the carbon CO2 emissions per pound or kilogram of payload that is, lifted? We know that lifting a payload might not be the most efficient way compared to, say, a flat transportation method. So just wondering, what research has been done? Is there a net figure that we have for different, a small drone, a large scale drone, and a short takeoff aircraft?
No, it's active. There are people who look at battery management for this, and it's an active area of research. If you take electric powered vehicles, you actually need to charge these things. And if you have a larger aircraft, you can imagine that the charging infrastructure, so you can have an existing airport region that's there, but you actually have to build and imagine something that's very similar to the challenges we face with EV charging infrastructure with cars, but now at a much bigger energy density ratio. Absolutely. There are people who are working on it. There aren't single numbers there, but there is an understanding that there's going to be a strong implication here.
Okay. I think the last question, there were a couple of questions, on privacy that, shouldn't the people who live on the ground and have nothing to do with the things flying, above them have a say in the matter as well? Do you want this? So we know drones have a ton of sensors, cameras, this fly past your bedrooms. Do you want this to be happening at all? Is there societal benefit to the overall growth of drones from both the delivery and passenger perspective?
That is a good question, and we there are a whole bunch of privacy questions here. You can think about there need to be mechanisms, and actually I saw Vishwa Bulsu somewhere here, so at Berkeley, and then he's now at NASA Ames, but they've done work on essentially looking at, I want a cone of silence over my house, right? I don't want drones flying over my house. There's also other implications with package delivery. So, that people have looked at. What happens if the package drops, my neighbor's package drops into my house instead of my neighbor's, right? If the most efficient way to deliver something to my neighbor is over my house, does that happen? I think these are areas where regulation really needs to speak up. There have been cases of people actually taking down drones over their homes, right?
I think twice before getting a skylight installed.
Privacy of customers, privacy of people who are buying packages, privacy of people who are just underneath and not, bystanders in this. That is probably, the societal acceptance question is the biggest one here on would we be okay with this, right? And that's one that all of the demand projections have ignored to a large extent, and we don't know.
Great, it's 1 o'clock now. Sorry to cut the conversation. Thank you so much again, Hamsa, for the presentation, and also Tom, Alex for the comments. Before I conclude, I also acknowledge that Professor Amadeo Aldani is here, who contributed significantly to this field. Thank you for joining us again. So everyone, please join me. Thank Professor Hamsa Balakrishnan for the presentation.